Hello, hello, and welcome to the stream. My name is Chris. This is Fully Defined, and we're going to be doing some live SolidWorks modeling. Now, anyone that catches the replay of this, because there's not many people watching yet, please jump in the comments, let me know what you think, and if you have any questions for future streams, just let me know. Send them through the Skool community. You'll see the link in descriptions, or in the comments, or on Discord, or anywhere you like. Hey, Metab. I'm doing really well, mate. How are you? Nice to see you on. Do you have any questions, Metab? That's the main aim of this stream, helping people out. But I can't just sit here waiting for people to jump on. I need to be doing things. And I have many things on my to-do list, most of which involve DIY projects for home at the moment, which is the thing here that I'm going to show. Now, there's something else I've linked in the description for this stream, which is a dishwasher tablet dispenser. We will get to that shortly, but this is my priority tonight because I want to get this on the 3D printer. So I'm going to show you a bit of the background on this, explain where it's at, and then we'll just go through the process of improving this design. So what is this that we're looking at? It is a charging stand for a Xiaomi Smart Band 9 Active. Right, so this is from MakerWorld, from Naren Koenig. And I've got a 3D print of this, which I will show you. Let's have a look here. All right, so here is my redesign. Now, so this would be called a remix, but I haven't uploaded it yet. I haven't uploaded any files for 3D printing. But I took the design that was here. Let me look at this one. So I took this design and I tweaked very few elements. The changes that I did make was to this bottom section. You see how this print was done in 2 pieces. I combined it into 1. How did I get the measurements? Well, I can show you that process. I'd be happy to, actually. I didn't record when I, converted it to this, but I can very easily show you the process. Because obviously, if you're downloading an STL file or something like that, it's not going to be parametric. So my process was, and I do plan on doing a video of this at some stage, on MakerWorld, you can download the CAD file. So I downloaded that. Now it opens as a zip file. There's 2 files in this folder because it's 2 parts. So I'm just going to bring them out into my downloads folder. You have to extract them before you import them. And then let's try and import those. So you can see them here. Preview those 2 files. If I just bring one of those up into SolidWorks, that should import for me. Let's see how that goes. Okay, so it's got a lot of faces. It's a mesh. We're going to import it, and then I'm purely using it as reference. So, the design that I could see that this user had created had a few good ideas to it, and I have the watch here and the other parts to explain it to you. Just while that's loading, I'll show you. So there's the charging cable. So it's a special cable for this watch. This watch is for my son. Here's the watch itself. So on the back, you can see there's a charging point. Now that's magnetic, so they snap together quite neatly. And so in this design that the user created, the cable sits in the top here, and then the watch comes over the top and snaps on and connects. The trouble with this design that we found is that it's very lightweight. Okay, so there's not much in the base holding it down. So if my son wants to take it off, pull it off, it's quite fiddly, Also, this pops out too easily. So there are things that I want to modify to improve the design. Now that import is still going, so I'll just talk about this for a second more. The other thing on this watch band, it had this little clip here to hold it together. That got lost on day 3, so I've had to redesign and print a new part there, which is still a work in progress. So yeah, we might do a video on that another time. STL to solid is a good skill to learn. You get the perfect time then, I guess. I reckon so, Matab. Just depends how this file loads. So it's still loading. I could say last time when I did import this file, it just took a while to get both bodies open. Probably took me, I don't know, 5 to 10 minutes. And it was 2 separate files. So I think I put it together in as assembly, as a combination assembly, and then saved it out into a part file, which is the one that I did have open here, but I'll bring that up again. And then I just used that as reference, rebuilt my new geometry, and then deleted the original. I thought I'd never need it again, which is why I don't have that file just to open up quickly for you guys. But yeah, I've got my step file. That's my export that I used for 3D print. So, okay, here we can see the import. All right, now the scale is correct. So if I was to measure this section here, I can see it's about 21 millimeters. So the scale is right on for what it was. If we control tab over, you can see my design here. If we put these two together in an assembly, we'll be able to show the difference between the two, or the similarities. So you can see where I've tweaked my design, and then some of the little refinements that I made just to get things kind of matched up. So here's my revised version. I'm just going to fully define this in position. And then the import here, I'm just going to save it this time, which I didn't do last time. So I'm going to save that. Once I've saved that file, I can insert it into my assembly. And it's a bit slow to save. How big is that file? The mesh always makes it quite big, even for simple geometry. Still going. 51, look at that. 51 megabytes, that import. All right, that's saved. Now, if anyone has any questions about my hotkeys or shortcuts along the way, let me know too. So here in the assembly, I can insert component, bring that other STL file in. Now, it's not easy to mate and orientate this because I'm pretty sure it's going to have different origin. And looks quite slow right now. Very slow. Come on. All right, we can see it's plane, its right plane is there. And so that's different to mine, but we'll just get them mated up for reference for now. I just want to show this quickly as reference, then we'll move on to the other example, showing you my changes. So I'm going to make these two faces on the bottom. Again, very slow to select. All right. And I'll just slide this back now. So here you can see very roughly, I'm just going to change this mate here, just to move it over to the side. And let's go 30 mil. All right. So that gives you a bit of a comparison. So I didn't change too much at all. with the original design. What I did, I basically created new sketches for everything. I used it as a reference, particularly like this opening here for the cable. I used that as a reference. I wanted to skip having to measure this, but I'll probably do so now. And then I used a lot of the fillets and the size and kept it roughly the same. You can see from like this front view here that this section across the middle, I spent some time like thickening that up. I put some fillets on some of the edges. Just all in all made it a bit of a smoother design. And I also changed it deliberately so it was just a single piece 3D print. I didn't think it needed to be two separate parts for a 3D print. I was quite happy to print this as is. I'm not sure which orientation it was, but it had very minimal supports to it. You know, it might have been a little support in this area underneath here. So yeah, that was easy enough. Off-road 5246. Yes, I have a space mouse. That is what you can see just over here. Yes, but I do not use it all the time. I should use it more. Just takes a bit of getting used to still. I've only had it for about a year. I have many hotkeys in the tab. Yes, that's right. Okay, so let's get into refining this design now. So I'm going to kill this assembly. I don't need it. It's slowing up my system, and I don't need this original file. I'm just going to work on my parametric file here so you can see how I've built this. I'll just take you through that very quickly. Started with a very simple revolve for the base. You can see the units here. It's going to like 5 decimal points. That's what the original file had, but if I wanted to change that to simplify things, I can just go here to dimensions and change the primary precision. I'll just bring that back to 0.2. And so now when I look at this, it just simplifies all those. I'm used to working to 0.2 dimensions. I have a cut. So you can see like this detail, this is the original detail, but I no longer need it. So in the end, you know, I did originally model it much like the original creator as those two parts. So that's a cut. Here is a boss extrude on the side, so a lot of driving dimensions in this sketch. G'day Dennis, Space Mouse, best thing regarding CAD designing. I think it's very good. Yep, it's just taken me a long time to get one here, get one at work, and get to using it. But I am using it more and more. It's just slow to, you know, completely change over, understanding how to move instead of using a hand on the keyboard all the time. So driving sketch there with a couple of features. So similar sketch, but then one base feature, one side, extend out, and then a cut. So this was quite detailed here. So this is one of the sketches that I will probably tweak. A couple of fillets, and then I decided just, you know what, let's combine the whole thing, fill in the area at the bottom, and then add a lot of fillets to finish off. All right, so that is the original design. Let's make a few changes now to fix what is wrong with this and make it a bit more stable. So I'm going to start by going, I'll show you the clearance with tab, but yes, it did have some clearance. I'm just going to say this is version 2. So let me zoom in. So you see these two components here. We'll measure this in a second to see exactly how big it needs to be. All right, but this part, which is the dimensions from the original designer, it's too loose. All right, I wouldn't mind it being sort of a tight fit like this if maybe this had a little clip here. All right, so once you push that in, here we'll just have a little bit of a round section that will hold it in place. I think that's probably a very easy solution to keep it front mounted like this. Another way you could do it, because the problem with this, right, in this design, is that this is magnetically attached, right? So when that goes on top and that's charging, but then my son wants to take it off, he pulls this off but that comes straight out with it. So really this should be underneath. Okay, so instead of the hole being on top, the hole should be on the bottom, so that this gets assembled from this direction, so that when this is being pulled off and separated, this can't come with it. I think that's a key change we're going to make. So I'm going to change that. Look, this is quite strong here, like I could snap it if I really wanted to, but that doesn't really need to change. I would probably like to make it symmetrical, but you can see with the design here why that's on the side. Okay, so the band can come on and off. Now, the other thing that might be easier for me and for every other right-hander out there is put the left hand on this and this goes on the other side. That might be easier than this current design. Or maybe there's a way that this support doesn't have to be at the front at all, particularly if the band isn't done up like this. I know on my watch that I've got, let's put this clip over here, my watch holder, I'll just put it around over the top. It doesn't even matter so much, but yeah, we'll have a quick look at that too. So a couple of great comments here. Off-road, how did you reference the original model to design yours? Did you have it in the background of a sketch or something? I had it in CAD. So I had it on my screen here. I had it on my screen like this, and I was actually building this CAD around it, and I was just making sure that when I was sketching it, so any of these sketches that I was creating, I was making sure I wasn't referencing that model, because when I deleted that model, I didn't want to, have a bunch of hanging references everywhere. So I was originally basically designing it one for one, but then after I got rid of it, I knew which features were important. I was able to redesign and tweak a bunch of the dimensions to be whatever I wanted them to be. And Dennis, great comment there. Many people have a hard time learning Space Mouse because they have zoom as pan forwards instead of forwards backward instead of pull up down. It's definitely taken me a while. So the Space Mouse that people haven't seen is this device here. And instead of using your mouse here to move around, the Space Mouse, you can see here I can tilt to one side, tilt to another, turn to rotate, push down, pull up to move up and down, push forward to zoom out, pull back to zoom in. So you try and combine all of that into kind of very distinct like movements, and it's very, very sensitive. It takes a bit of time to get used to. Of course, I'm used to doing everything with a mouse, usually a middle mouse button click. Really a lot of middle mouse button clicking and scroll wheel, but this is much more comfortable. We'll talk about that more in another time. It's a really good topic to kind of chat about. All right, so let's work through our changes. First change, we're going to just do this on the fly. Do we need to change this detail at all? No. The size clearance for this part is okay, but what we are going to do is put it through the back. Now, before I do any of these changes, what I'm going to do is roll up my roll-out bar on all of my fillets. Well, the other thing I could do is suppress them, but I want to roll up because then I can just roll them back down later, even though a lot of them are going to change. All right, so that's rolled up. This detail is what we're going to tweak here. All right, now I'm happy with how that looks in close. All right, I might put a few little radiuses in, like see that radius in there, and see like that corner. It's quite a bit of a gap there. Doesn't need to be there. We could probably just close that up a little bit and it might look a bit neater. Also, it sits flush enough. That's okay. But what we're going to do is make it come in from the back. So we're just going to reverse how that cut detail is done. It might take us a little bit of fiddling around. All right. Now that cut is back up here. So what I'm going to do in my feature tree, just roll back up to where that cut is. Just refresh myself of how that cut is done. And the distance. The distance is 10 millimeters. And that left me, as I can see here, 2 millimeters at the rear. All right. So I'm going to edit the cut feature, and the cut is starting on this sketch. I'm going to change it to start from this face and reverse the direction. It's going to come up the other way. All right. So here, right now, that part would now come up from the back, but I need it to come up all the way to the top. So I actually need to offset it from that face. Just thinking here about the process, what we're doing through, because perhaps we don't need to change the cut at all. We just need to add on the material and change the back area. This is really this side and that end that we need to change and fill in some material here. So this is what it was originally. Now we can see that it's the square area that remains the cutout, which means all we have to do is fill in this section. So I'm actually going to just grab this and this and this. So no dimensions here. See how I use those three constraints? I use that corner, I use this edge, and then I use this edge to create that rectangle. I'll show you again. So use mouse gestures to get my rectangle tool. I'm going to start on this corner. If I just went down to this corner here, I would have to put in a dimension or another relation. I can go to this edge here and then grab this one and drag it over and then get it to be coincident. So no dimensions, it's fully defined. I'm going to extrude that one down 2 millimeters. That's going to merge result. All right. So now I've got that shape that I need, but I can cut out the back. So all I want to do here, I don't need to, do I need to cut out the whole thing? Yes, I do. So this cut extrude, which was previously 10 millimeters, I can actually change that to just go through all. Now I don't want it going through the back here of this one. So instead I'll go up to surface and change it to this face. Press OK. All right, so that's changed it now so that this will fit up from behind. Here's where we can add some of the other details we want. I think I have here the fillets, a couple of fillets. Let's see what these fillets are. So there's that fillet on the back. I'm going to move that one up, okay, just to separate it, and then another fillet here. That one's also on the top, don't need that one. So I haven't really done the fillets in this section. Let's just see if I had them anywhere else. Okay, I had this fillet here, a couple of fillets. So those are the ones I'm going to use. I'm going to drag those up in the feature tree. And I'm just going to roll back up. All right. And those two fillets, they're the ones I was saying is too small. Now I have this tool that I'm going to show you, and I will put a link to it somewhere at some point, but forgive me, I don't have it yet. You can probably find other examples of this tool online already if you have a 3D printer. When I first printed it, I needed it for one thing, and I thought, oh, I'll probably never use this again. I'm starting to find I'm using it more and more. It is a 3D printed fillet gauge set. Fillet gauge set, fillet measuring set. I've got here radius 1 to radius 10, and what it lets me do is pull out this little thing, and I can see on this side I've got R1, so 1 millimeter radius on this corner, and a little 1 millimeter like concave cut on that corner, and then this side is 2, and you can see the difference here when we get up to, I go up to 11 and 12. This is for measuring the radius of a part. So this part here, I don't have to guess what the radius is. I can use this tool to get pretty close. Now, we already had a 1 mil dimension in our drawing, which is not correct. And we can see why. If I put this 1 mil here, it's nowhere near big enough on that head. So I'm going to pop that down, and I'm going to go for, I think it's probably more an R3 or 4. So have a look at this one. That's too big. Go around to R3. That's a little bit big. All right, I'm sorry I'm not very zoomed in on that detail, but you get the idea. that is a little bit big. I reckon if I had a 2.5 or 2 actually looks really close. So why don't we do, like if I bring that right up there, you can see not quite in focus. R2 might be the way to go. So we go into our CAD and we put that R2 in there for this radius. So where I had this R1, I'm going to change that to a 2, edit that feature, and I'm going to grab these edges. Now I've got a few issues here. It doesn't want to do that edge for me. This one's not going to want to do it either. All right, reason for that is the other kind of detail that's the original designers put in to kind of cut around on the cable, which I think is kind of unnecessary. If we have a look at this, you know, all those little edges in there, they're not actually doing much. You really just need the bit that comes across and then a curve at the bottom. So I think we could simplify it, yeah? So I'm just press the tick, just change that radius. Just gonna save and just gonna hide this body for the minute, I don't need it. And go back into this cut and just see what I can simplify here in this detail. All right, because it's got this little cut, chamfer, line, cut, chamfer. But in the 3D print, they're not really doing anything. I'm happy with how it fits at this first corner, so I think I'll just cut down all of that. So I'm going to go trim tool. I'm just going to remove all of those. Do the same on this mirrored side. I'm going to extend that out. I'm going to trim this one. When I trim this one, it's going to remove that dimension. Cut them off. Extend, extend, cut, cut. And then I'm just going to add some relations back. So that's horizontal, that's vertical. Because they've already got that 5.2 dimension there, they stay the same. So that shape now is a lot simpler. The other thing that I could do to save my time with the fillets is put the fillets in here. But I will get an error because this edge is only 1.3. Let me get my calipers out and double check what dimension I need. Smallest radius went inside, yes. But I like to live dangerously and try and go right to the dimension. All right, so that, like the cable part there, pull this out for a second. Yeah, the main section here is 4.5, right on the edge, the thickest part, 5. So should I leave that as 5.2? Probably. Let's just do the fillet and it will kind of cut off. So I'll leave the fillets out of this, accept the sketch. 2 mil radius. Now it's going to do it, and you see what I mean? It kind of cuts it off there. That's what I'm after. I'm very happy with that detail. All right, next, my point earlier about how this goes in and out, we just need a little clip that holds it in place. And this part is important because I need to know where that circle is. Right? We don't currently have that because we don't have, you know, the user hadn't done a CAD model of this to include it. So I might actually do that here. And I'll show you how I take care of that. I'm going to start on this face. Start on this face, a new sketch. And we're going to do what we probably should have done much earlier. I'm going to measure 16.2. Now if I show this cut, extrude, it's not going to help me too much. I'm just going to sketch it. 16.2 by 7.7. See how that fits. It's pretty tight. That's fine. I'm going to line up with some midpoints. So you see how the clearances are done in the original dimensions. It's very tight vertically, not very tight horizontally. So we might tweak that. I'm just going to measure twice just to double check. 17.7, sorry, 7.7, 16.2. All right. And we set a radius of 2. Might be slightly bigger, but let's put that in. Okay, so we see we're currently fitting, but this could be a bit bigger. So this is 0.1 bigger that way, and there's no dimension here. Let's put this dimension in, 16.6. 16.2. So it's got 0.2 outside and only 0.05 vertically. Let's keep 16.6. 0.2 on the 3D printer. It's probably okay. I think let's just bump. The fit was already all right. Don't need to change it too much. Let's bring that down so it's kind of 0.1 everywhere and make that 7.9. Just looks more balanced. Even though the radiuses there are the same, we'll live with that. Okay, so we've got that feature. Then the thickness of that, 10, right on 10. Now, the reason I'm doing this will become clear in a second. I'm going to unmerge. I'm going to flip the direction. And then from the side here, I'm going to put in the cable position. Now the cable at the very bottom point is slightly bigger. Bit of cable, bit of stress relief. 5.4. I'm going to isolate this body and go midpoint to there. And I can't use horizontal because they're at an angle. So I'm going to have to do a construction line. Make that for construction and make those two lines parallel. Okay, so now it's in the middle. And that 5.4 is almost right to this edge. So it's basically like that. I think it's going to be about 2.8 from the bottom. Okay, now that little section only goes out and say like 1.2 millimeters. So I'm going to do offset 1.2. There's a few ways you could do this, and I'm going to go that direction up to next, and it's going to merge. All right, very easy way to do that. Then the next section of the cable is 4.4. I've got the center point now, so I just need the diameter and the distance to extrude it. I'm just going to measure using the inside of my calipers about 6 millimeters. This doesn't need to be perfect, so it's okay. And then the last section of the cable, so the cable itself is 2.8. 2.8. Extrude that, and I'm just going to extrude that 20 millimeters out just to give us an example. The pins on the top I'm not going to worry about because all of this face here needs to be exposed. All right, I'm not just exposing the tiny area for those two little pins, so I'll leave it. So now I exit the isolate mode, and I'm just going to change the appearance of this section so that always stays really clear that it's not going to merge. Let's go blue. So now what we should see, this gives us a guide for what kind of 3D print we can put in this area to create a little clip. And we could even fill in this section, okay, to give it a bit more strength or make it look a bit better, because this part will never reach up to that height. You understand? So let's go through that process now. I think I'll do it with a sketch on this face. And we have, this is the curve here, this is the one we want to push through a clip. Now, I'm just going to be guessing and eyeballing this. This is the kind of thing that there are formulas out there to work out exactly how far it might like open up as you snap something in. But these are so small and it's just PLA we're printing in. It should be quite easy to kind of separate it out and get what we need. I'm going to just put an offset of 0.2 for that. All right, doesn't look very much yet, but just wait. We're going to do as well, just going to sketch around it. Now to start, I think I'm just going to do something like this. We'll probably tweak this design, right? But I just want to get the shape in, and then we'll start talking about how exactly we're going to tweak it. Now, I know it's a bit hard sometimes on the angle. I sometimes like to get to a view like this where I'm looking at something straight up and down, even if that part is on an angle. I'm going to make these two collinear and equal. I'm going to make these two lines also equal and parallel. And you can see the opening here that we're creating. I'm going to trim away this section. So if we look at it like this, for instance, or this shows a bit more clearly. Even if I press shaded sketch contours, that's going to show you more clearly what we're creating here. Now, all of this plastic is going to join into these surrounding faces. So it's actually not going to have a lot of room to flex out. We don't want it to flex that hard. It should be like a one-time fit though. So got to press it in hard one time. That's probably okay. Let's look at this face here. I think about, let's go 1.6 millimeters. And if we look at some key dimensions here, we've got this cable that's 4.4. Just gonna make that for construction so I can get a dimension off it. All right, and that opening is 3.4, basically. So we're asking these walls to try and flex out 0.5 millimeter each. Now, that might be okay. It depends on a few things. It depends on how flexible or stiff the material is on this head. All right, if this is kind of squishy and it will squish through, well, that's okay. If on the design here, the material here can flex out easily, that's probably okay too. As it stands, I'm not exactly sure if we've got that right. Now there's no controlling dimension here. I just want to work out what's controlling that position. And I've got those equal, because this here I thought might have been driven, it's the length. I think this 1.6, yeah. So if, hold on a second, equal. We can move that up and down, but I want to move these out. I'll work that out very quickly. Uh, 19 viewers, wow. Thanks for jumping on, guys. If you had any questions, please put them in the chat. I'm not quite following the planned episode where I was going to do a design from scratch, but I think this seems a little bit more interesting right now, so I don't mind it. All right, this is what was controlling the dimension. I didn't mean it to. There's this vertical relation here between this point and this point. I actually want to delete that because I want to be able to control the opening dimension. With that done, I can just put these two back as they were, and now you can see I can control this. So I'm going to change this dimension here to driven. I'm going to put this one back to driven as well. Let's set that to 1.5. And so our opening at the moment is 3.9, whereas the diameter is 4.4. Another way we could dimension between those two to see how far those walls need to open up is I can dimension this line here, hold shift, and dimension on this edge. And you can see here that to squeeze through, I'm trying to squeeze through 0.26 of a millimeter on each side. That seems okay. I reckon I could go a little bit more. And if we think here about the process that we're going through, this is going to be a 3D print. It's going to be PLA. If I get the size wrong, I always just change the detail, do another print. It's not going to cost me that much. Or I can make it small. If it's too tight, I just get a sander, a file or something, just take off a little bit of material, and that would be fine too. So you know what? I'm going to close it back up to 3.6. So it's 0.4 each side. And if it's too tight, I'll deal with that later. All right, so we're going to fill in that area. The other thing that we can see here, based on our dimensions, this is currently interfering. So we will take out some more material to get rid of that. Make sure that fits. Let's do extrude here. We're going to fill in this space. Hello, Jay. 4444U. Can someone tell me what is the best software for 3D printing and making models? Free. Well, you almost get your choice these days. It depends. Do you want to make your own models, right? Do you understand CAD? Are you a designer? If not, you might want to start with something easy. But I don't know, what is the easiest? Maybe anyone else out there that's not a SolidWorks user could answer for him. There are a lot of different options and a lot of different resources. Yeah, good luck. I teach SolidWorks here. If you want to learn SolidWorks, I could definitely help you with that. All right, so I'm going to do this extrude here, and you can see I'm just working on the number. 4 millimeters gets me really close. Let's just back that off to 3.5. And when I'm ready to complete this, I'm just going to auto select or uncheck auto select. So merge with this body, press OK. And now that's creating that face. The other thing that I might want to do here, I might not want to cut into a really sharp edge like this. So I can either put a little radius on it, or I could, draft it outwards. In this one, I think what I might do is draft. So I'm going to use the draft tool. Now, of course, you could draft it in the sketch itself. That's another way of doing it. But I'm going to just do a draft. I might just do 5 degrees. And I'm going to go from this face and these two edges. So it's going to just open that up and just make it a little bit easier to squeeze in to start. And then, even to neaten that up, I can put a little radius on these so it's not a sharp edge that's starting the whole thing off. All right, so draft and then hold in place. And hopefully that's going to be tight enough to hold it. It actually looks a little bit clear, like the clearance is a little bit bigger than I'd like. If I remember, this is 4.4, this is 4.8. That bigger circle, because I did 0.2 clearance. Let's just put that down to 0.15. All right. Okay, that's that bit. And then we want to do a bit more clearance around this one. I said earlier that wasn't quite right. So an easy tweak there. Let's just have a look at a section view. So from that face, if I bring that out a little bit. But that one, we can sketch on this face. If this is reasonably accurate, which it should be, I'm going to use that center point. I'm going to do a slot straight up because that's going to give me the clearance that I need. All right, let's go a normal 2 view, delete this dimension. This one just needs to be clear. So this one I'm not concerned at all with being super tight. The main thing I want is for these to be perpendicular and for that to go all the way through, which it is. if I drop that up here. So I've got that slot there, and that slot, I just want to cut that through into this section here. So if I isolate this body, do a extruded cut, I just want to make sure that comes in. Let's go up to vertex there. Right, so it's just giving me that little extra clearance. That explains why the original design had those little funny edges. You know, that looks a bit better, I think. Off-road says Onshape, favorite free version, or Shaper 3D for iPad. I've never done CAD on an iPad. I think it looks horrible, but that's only probably because I like doing detail and parametric design. So that's okay. I have heard that SolidWorks will be going free for students in July of this year. So that'll be interesting. For anyone out there learning at uni, at college, high school, wanting to learn SolidWorks, it's about time they did that. All right, so that is going to do us a lot of good for that component. Yeah, I really like how that's looking like it will clip in now. I don't love the rest of this shape, but I'm not too concerned with that right now. I think we can come back to that. If I was really, worried about it dropping out or that kind of thing, what we could put in is we could design like another part that fits over the top and kind of snaps in, but don't want to do that just yet. No. That was the main design change we wanted to do. So here's the original design for anyone that's just jumped on. The original came from MakerWorld. This user here, thank you, Naren Cohen, very much. I will, show you. I will try and boost and comment for you later on and post the remix. We have done the main tweak we wanted here, which is get that cable in. Now the rest of it is what else can we do to improve on this design? So that cable will now pop in through in the back, and that should stop this from falling out. All right, that's the first thing we wanted to do. Other things we wanted to do is then make this a bit nicer and maybe give it a bit more structure. All right, because it's very lightweight. And my son, when he goes to take it off, often he's leaving it like falling down on the desk. So we might have to make it a bit bigger, which I don't mind. We've got plenty of space. So currently that snaps on. It's actually quite neat. It's all central. It looks like this is hitting a little bit because I made this bigger. So it's kind of pushing it off center. You see, it's a bit hard to see there, but you can kind of see it here. So I think, yeah, maybe I need to do a bit of a thin it out or something. I don't think there's any other way of getting that to sit. Like if we did something from the back here, it would mean you'd have to undo this all the time. Could that go either way here and then it clips it on? That could look cooler. Could definitely look better. Is it going to get in the way? If he just goes with his assembly, like putting this on, if he loops it like that, having two parts here rather than one at the front, that could look pretty good. Putting a few coins underneath the stand, I'd say. Not bad. Not a bad idea. For a little bit of weight. Just wondering. You know what I'd say? I think that's a really good idea. I've got a few coins. Do we have measurements? How would I do it? I probably want to capture them in the 3D print. So make a cavity in there, pause the print, put the coin in, print over the top. Can get a bit messy, but could be all right. Yeah, definitely like the idea. We probably don't need to make this too fancy here. I think what we'll do, look at the time, we're an hour in. I think I'm just going to modify it ever so slightly and just push this edge. We'll just cut. I don't want to make a weak point there. That's my only concern. You know what? I think I'm overthinking it. I think it looks right on the edge and it's pretty neat. I think let's just strengthen it up from the bottom, bring this out so it's not round, and make a cavity for a coin. Give it a bit of weight. Let's see if we've got dimensions of a 50-cent coin. Australia. There you go. Australian 50-cent coin, diameter of 31.65. How thick is it? Approximately 2 mil. Okay. Approximately 2 mil. That's probably pretty good. Hey, Jamie Kirk. Do you have any experience with Inventor Fusion and transitioning to SolidWorks? Sorry, no, I do not, because I've always used SolidWorks. So I've tried Fusion like for half an hour, but transitioning, no. But I do have a lot of content that shows you how to do things in SolidWorks. That could help. If you're experienced in Fusion, a lot of the tools will kind of be the same. They just might have different descriptions, slightly different workflows. I'd say suggest make a slot slightly larger than the coin underneath and use hot glue gun and stick it. I don't want to use a hot glue gun. That's another process. Making a slot could be okay. Like you just put a cut here and you slot the coin in. But that slot, like it's going to fill up with support and stuff. I'm not going to be able to empty it out. I really just want to leave a cavity and just put it in the print. I think I'm going to do that. So let's roll down on the design here and let's see where we're at as we clean this up. So that had a couple of fillets. So this is all the fillet work that I did last time. I don't need to change any of this. I'm going to hide, I'll keep that there for now. A couple of fillets that are broken, this front edge one. Now, I don't need this front edge fillet anymore because this whole component is coming in from the back. All right, so what I might do is put it on the back face. FPV Kev, hello, by the way. Good comments there. Pretty much the same. I don't know because I don't use Fusion. I can't tell you. I'm going to clear all missing references. I'm going to clear all references. And I'm going to just put a fillet on this back edge just to make sure that gets in okay. And this is the point where I can clean up these other elements. So I'm just put a little fillet there and little fillets here and here. That one's going to kill it, so I'm going to take that out. That one I'm going to change. You see this curve here? This curve's been stopped, so I'm going to come back and change that too. So I'm going to press OK on this one, edit this feature, and just get that one continuing. There we go, that looks better. Then I come back here. Now this one is not working at all. I'm just going to remove this fillet. That's okay. This is the back of the unit. No one's ever going to see that. So I'm not too concerned with how that looks. This edge, it's okay. Let's just put a little 0.2 mil radius on it. And those two. All right, that's probably enough finessing there. What else do we have? Had this fillet, which is gone. I don't think we need that anymore. Off-road, thank you. Maybe you saw my dimensions here. It says 31.65, yep, by 2.4 thickness. Beautiful. It says approximately 2. Should I go downstairs and get one, or should I trust the 2.4 millimeters? I think I'll trust one of my viewers. Thank you very much. And 26 concurrent viewers. That's great. I think in my last stream I had 5. So maybe we're finding a bit of a theme here for topics. Modeling designs on the fly and 3D printing could be the way to go for the future. Okay, this design's looking good. That coin, it's going to be 2.4 thick. Our thickness of our base is 7 millimeters. Don't love that number on its own, but that's okay. So let's go into the center of this and put in our base for our coin. We'll have it up like this, which means I'll just make those two vertical. The size of the hexagon, 31.7. So I'm going to do 31.9 across the flats, and then 2.4 thick. So what we're going to do is an extruded cut, and we'll do it 2.5. Now remember that the thickness of the base was 7 millimeters. So I'm going to offset this. I'm going to put it right in the middle. So I'm going to offset this 3.5 down and then make the cut mid-plane. And it just works out to be exactly in the middle for me. Cut extrude there. Then what I'll have to do when I set up the 3D print is make sure I prevent any support or fill material going into that slot. Right? I don't have my 3D printer connected to this computer, but I do have, long story, 2 different computers, different 3D printers. I can set it up here on screen though, so I will do that for you guys, just to take you through that process if you haven't seen that before. All right, and this body, like I'll keep it there, but I'll remove that from the 3D print. Anything else that goes in this 3D print then? We're pretty good. Yeah, the coin's to add some weight because it's not very heavy. This whole thing is PLA when I'm printing it. If I applied some material to it, I don't know what material is close to PLA, but let's just use ABS for instance. The mass of this part on its own is only 24 grams. So then you got the cable, and when the watch on it, the watch weighs more than this. All right, so it's just to add a little bit more, so it's got a little bit of stability there. The coin's only 15 grams. It's not going to add that much, but yeah, it will add 60% to it. It's a good little experiment to do. So we can see that clip detail we're going to put in. I think this looks pretty good. 24 grams is very light. That is the ABS. Maybe the PLA is a bit heavier. We can always print it very densely as well. Let me take you through the 3D print process. I'm going to save this as a step file. I know you can do STLs. I just like using the steps because that's what we normally do when we're sending files to our suppliers at work, and this way I don't have to save 2 different files for 2 different things. All right, let's open up Bamboo Studio. So the printer that I have at home is a P2S, the brand new P2S. Now I have 2 AMS2 Pros connected. I don't have a lot of different materials, I've just got a lot of different colors. But the Bamboo Studio printers are fantastic. I won't spend too much on this because I'm not a studio or slicer expert. I'm a SolidWorks expert, but I just want to show you what the plan is for setting up this part and how I would do it. I think it is useful to know and understand, the reasoning behind certain decisions. Let's just get this in place here. Connecting, okay. Someone's got an issue at work. That's fine. Now these are my work 3D printers, so it's not my home one, so I won't actually hit print here. But I'll just use them to show you how to set it up with the materials. So I've got my file here, version 2 active doc. Drop that in. That's going to load up, and I've only got the one body, so that's good. I'm going to print at like a high quality level. I might even go to a fine level later, but I think high quality is probably okay. I want to use support material. I'm going to enable support. I want to use the support material as the interface. And then I want to let this tool here tell me the best orientation. And it's telling me to do it this way. The other thing I'm going to have to do when I slice it is add a pause in. And let's just check it doesn't put support in the material in the middle too. That's the part where I might have to put a support blocker. So when I go here, slice plate, it's going to do the preview. All right, so it shows how where those supports are. So you can see it's doing a tree, 3-hour print. That's pretty good. Changing filament 35 times. That's not great, but you know the amount of filament being used overall is like 56 grams. Not much. Like that's a 20th of a reel. And then if I roll down here, we can see the infill. So the quality, the strength, we've got 2 wall loops, which is probably enough for all of this. You can see how it comes down here. So then when we get a bit lower in here, this is where we see what it's doing in the middle. And so see all these supports that are in the middle here? I want to get rid of those because I obviously want that to be empty. And then I want to put in a pause when it gets here. So then it'll print on the top, or pause might be, you know, this level. So I can put the coin in and then it will print over the top. Now I might get some trouble with that print over the top because that print might not sit there. It might make it really messy. There's a big risk with that. I might have to put the coin on, put some masking tape over the top so it's got a smooth layer rather than the sort of the metal of the coin. So that's something I have to keep an eye on as well. So back here, I want to go prepare. And now this I haven't done too much, but we'll see if we can do it. What we want to do is go, I think we want to go objects, and I want to add a support blocker, and I want that support blocker to be, can be a disc or a cylinder. Okay, and I'm going to put that in the middle like this, and I just have to get it to the right size. So the support blocker, this is where you can tell I haven't done too much of this. I'm going to scale it, and you can see the size here. So if I make it 40 by 40, X 40, Y 40, Z uniform, doesn't need to be that big, 10. Okay, scale's fine. Reposition it. Down. And just in the middle. So it's just going to block any support from that middle section. Hopefully it doesn't cause me an issue anywhere else. Let's go slice again. Hello, Huma Murchie. Which engineering should I do for future proof? That's a big question. That's a really big question. If you become good at any of the engineerings, you'll be fine. But it takes practice. Yeah. I don't have a really good answer for that. I'm sorry. Okay, so we can see that slice now, and we go down here. You can see it's all open. Okay, it's blocked any support material here, which is great. So then I would roll this up to this level here, and just go one more level down, so 29, and go right click, add a pause. That adds a pause in that layer. That will pause the print, give me a notification. I can then go with the coin, put it in, put a bit of tape on the top, watch it print over the top, and then keep going. And we're done. So that's awesome. I'm going to save this because I'm going to send it to myself on my other computer to do the 3D printing. So I'm going to save it in the same folder. And that will be it. And maybe in another video, post it on YouTube sometime, or definitely in my Skool community, you'll be able to see the finished result of this. Yeah, it's quite neat. Okay, I'm an hour and 10 into the stream, but feeling good, and maybe we should move on now to either questions anybody has about modeling or things they want to see, or I can go back onto my original project. So like I put it to you guys, what are you interested in seeing? And thank you for anyone that jumped in the chat, jumped on the stream, or had a look or said g'day. Really appreciate that. I'd say thanks very much. I'll let you know how it goes. FPV Kev, Cura Slicer can do that. Probably. Cura has been around longer than Bamboo Studio. I'd say it probably could. Yeah. All right, just while I'm loading up the next one, remember, if you've got any questions, let me know. The original idea for this stream today, I'll get to that in a second. This stream is for, of course, anyone on YouTube. It's completely free. A bit about me. I'm a certified SolidWorks expert. I've been doing this for over 15 years. I have recently started a Skool community to capture all my content and lessons that I've been doing. Let me try and get my camera on. There we go. That Skool community is fully defined. It's pretty low numbers because I'm not really pushing it that hard, and I'm not really charging people to get in yet either. But it's somewhere where I can capture all my lessons and content and just build a little bit of a community. So if you are interested in having places to practice your SolidWorks, ask questions, and if you're interested in Lego, you might be really keen on this. So if you do jump into this community, you'll be able to find my Lego courses. So this is what I use or show to teach SolidWorks modeling. So the first series I did was this off-road buggy. I've then done this Volvo wheel loader, which I did via live streams here, and I've also done this motorcycle. And I've broken them up into a series of lessons where, like on the off-road buggy, you can start by modeling the 2x2 plate, and you can progress through all the parts. This series shows you how to model all of these parts and then put it together in like an assembly, and then let's see, like the final assembly, we can learn to do exploded views, all sorts of things. Anyway, this is all here, and we've got this library where if you want to practice any kind of geometry, you can go into this library. It's all free and all linked, and you can browse for certain geometry that you want to learn from, and you can download the SolidWorks file, or if you don't have SolidWorks 2023 on you've got something else, you can download a step file. And you can download the whole pack of files and do your own off-road buggy or your own motorcycle, or any of these assemblies here that I've done. So there, check it out. Join the community if you want, or don't. But yeah, I'd be interested to hear any feedback for anyone that has a go at these. Still pretty early on. But yeah, that's what the whole stream here is about, helping people out, teaching students, teaching other product designers and engineers how to get the most out of SolidWorks. I do have one paid course, which you can find on Udemy, which you can also find here, which is Designer Foundations to Certified Associate level. There's a free preview. It's more expensive here than Udemy. If you want it cheap, go to Udemy. Anyway, enough about that. Check that out if you want to. The project that I intended to do today was this, which I think is a bit more boring compared to what we just did, but it's something that's been on my list to do for a little while, so why don't we have a go? Off-road, modeling from a reference picture or model, but without links. Great question. Great suggestion for a topic, for something to look at. I wonder, modeling from a reference picture. Yeah. Okay, thank you. I will put that in the bank and I'll work on something for that for the next stream or one upcoming, because I don't have any really good reference pictures to work from. I can show you the process though with some examples here. So in the next hour, maybe a bit less, for the stream today, we're going to do this. I'm going to build a dishwasher tablet dispenser, and the reason I've been wanting to do this is because I've got like boxes and boxes of these things, 2 boxes, and we constantly get more, and every night I need to get one out and put it in the dishwasher, and I just want to do it in a neat way that's kind of cool, and move these out of a drawer and put them somewhere that's really accessible. Now I've seen there's a lot of examples from other designers online on Maker World and other places where you can kind of stack them or throw them in, etc. They're all pretty neat, but I don't really love the design of any of those. So the things I do like, I like them to be skinny. I like that they're vertical stacking. I like that it's visible, you can see what's remaining. I like the auto feed where you take one out, the next one will drop down. And I like where you get 1 tablet at a time, which means I don't know why you'd have one like this with 5 tablets at once, or 2 tablets here. This one, they show multiple here. You kind of pick from the box. That's okay. This one seems all right. Kind of like that one there. So it's just giving me an idea of what I want. So here, what I'm trying to show in this next section is a bit of a explainer of like design process and design intent. All right, I am a product design engineer, so I come up with ideas, and it's being able to take those ideas, put them into 3D, and explain or show other people, communicate what it is you're trying to build. FPV Kev, I like the stack types, gravity fed. Yeah, I like that too. The one issue that I have with the stack types is if I get a box, so I get this box of 50 pieces, do I have to sit there and put them all in one by one? Like, that seems a little bit annoying. I think I'd rather just dump the box in and have them magically sort themselves out and come down in a line. But with the geometry of these tablets, I don't think that's going to happen. So I want to find like a happy medium. That's the intent. So this is what I thought I wanted. Self-aligning. So dump the box in, it sorts itself out. Gravity fed. I don't know if we'll get all the way there. I need to fit a box of 50 tablets plus extra, so we never run out. A hopper. Interesting. Yes, Kev, I think that could be a good idea. I want to attach this with adhesive to the inside of the cabinet next to our dishwasher. So no screws, but I do need to have a flat area where I can put some double-sided foam adhesive. I want it to be visible through the left side to see the stock level. So it's going in a cabinet with the door that hinges on the right. So I open up the door and then I want to see it on the left. And I'm going to make it out of matte white PLA. That's pretty straightforward. So we're going to go through the process. We'll see how far we get. And talk through the thinking as we go. If you guys have ideas, I can build them in. So let's jump in. Brand new file. I'm going to start with a part, and we're going to start with modeling up one of these to give us some sense of scale. And maybe we're going to do a pattern of that to work that out. So I'm going to start on the top plane, and I'm going to measure this. All right, now this doesn't need calipers to be super accurate, and there's going to be some variance, but it's 38 by 27. So we go 27 by 38, And then there's some fillets there. They don't need to be super accurate, so I'm just going to guess about 7. All right. And then I want to extrude that up. Thickness of these is about 11 millimeters. All right. And then they do have, even though they're just these tablets, they have a kind of chamfer around the top edge, which is kind of neat, which slims them up a little bit. So let's put in that chamfer. That chamfer looks like it's about 3 millimeters, but the angle is very steep, about 10. So kind of looks like this. Maybe it's a little bit bigger. Yep. Maybe it's a little bit less, a little bit steeper. All right. So they kind of look like that. Let's save that as a dishwasher tablet, and we'll do a new folder. Tablet dispenser. Save everything. Ooh. So that's the folder, and then this is going to be the tablet. And so I'm going to then make an assembly from this. Is the audio coming through? Yeah. All right, let's just fix this. Camera is a bit slow to update, it looks like. There we go. All right, so tablets here. All right, we've got 1 in there, and then we need to make this big enough to fit 50 or 60. So I'm just going to use the origin to make this one. And let's just get an idea of scale, what we might be looking at. So I'm going to do a pattern. I'm using the front plane. I'm going to go backwards, and I'm going to go like 10 backwards, distance 20 millimeters, component to pattern, this one, flip. Now we said there were 27, so let's put in like 30 for the spacing. And then we want to go height, so we can go top plane for the direction, and they're 11, so let's go 12 millimeters. Put in the numbers, and if we go 10 by 10, that gives us an idea of like 100 tablets. Now that's probably more than we need, but let's see how big that is. So one thing I'm keeping in mind here is how big the 3D printer is. It can have up to a size of about 250 by 250. This distance here, 297. All right, so I think I'd go too wide rather than something like this. So let's change the pattern, and let's change this one to go to the right plane, but only go 2 wide. Change this to be 40. Change this number to be 6. So we'll give it a bit of space. Right? And then we can do another one, a linear component pattern, which has all of these components, but is just going up 12. So how many would that give us? 12 by 6, 72. So 84 is about this. I think that's about right. Twelve by 8. Calculator. 96, that's close to 100. So that's about the scale that we probably want. All right. So let's save that. Dispenser. Don't need to save it any different fancy file name. Plane is good. All right. And now the design. So that gives us a scale. I might do my part Well, let's just take some measurements. We can just go top plane, and this is not for sketching the part, but this is just to give us a rough guide to the size. So about 185 by 80 or 90. That size would fit. And then we can also measure like the height. So from here to here, 95. So kind of looking at about 180 long, 90 wide, 100 high. So that helps us get some sense of scale. So I'm going to start a new part file. And go on the top plane. And I'm going to start my design. Now I'm going to do a center rectangle. And so what do we say? About 180. So let's go to 200. And let's go to 90. And then let's go up about 100. So what do we think of these proportions? It's probably not going to be enough to do any kind of fancy hopper type thing. So we'll just go a little bit higher, and I'll just save that part. Dishwasher tablet dispenser, version 1. All right, now design constraints. We're going to have an adhesive side. So I'm just going to remember that, because that's going to be, let's say like this side here, this face. That's going to be adhesive. Also going to have an opening at the top, right? Which means it probably have some walls. Now for wall thickness, we can do whatever we want. Let's go 4. And let's just cut down as a starting point. We'll just kind of block in our design thinking here, okay? So it doesn't need to be super accurate. We're just getting an idea of what we're doing. We can work in like with some transparency, and apart from the red face, that's going to give us a bit of an idea of what we can see. I would like a kind of ramp. Like I am thinking now a little bit of a combination between like this one here and this one. I like this one sticks out a little bit. I think my laziness is going to mean it's not going to be a really neat stacking solution like this. I think it's going to be chuck them all in, but then have an open slot that I can just pick one from at a time. And I think that scale is pretty similar to what we're looking at here. It's probably a bit taller, right? Which we might end up tweaking towards. Now what we can, if we think about the 3D printing of this as well, that means we might print on a face like this at the bottom. So doing anything that's fancy and angled there might not work, but we can always angle it here. So one thing we can do is, let's just imagine we might cut something like this out. I'm going to do perpendicular. And how big a face will we need to get easy access with our hands? Maybe 40 mil. So let's go 40, and let's just put an angle in that makes it a bit easier. 25. And the lip to stop any tablets falling out looks about 20. Look at that. Okay. So let's do this a cut through all. All right. So that's giving us a little bit of a shape to work with. Now, before I did this cut extrude from the top, let's delete that. So this is the thing. Don't have to be precious about what you've started with and what you might be changing. It's all okay to tweak. If we do, what do we say our height was? 120. just go 130. I just want a little bit of an edge, extra edge here, so that I can put on a radius. And I'm going to come back. I'll come back to that. There's still plenty of detail to go, particularly internal detail. One thing, I do want it all to like lean down. So as, let's say, if we put stuff in from this direction, that maybe there is an internal wall which is going to make it want to slide down to the front. Now, I don't want to actually just cut off the whole bottom, because that might make the 3D printing more difficult. We can always change that later. So I'm not getting stuck on that yet. So what I'm interested to try is just a shell. I'm going to shell these two faces with a preview. You can see what that's removing. It's going to give me access here and access from the top to drop stuff in. All right, I'm getting an idea. So that side's adhered to the wall. There's a bottom here, which we can lift up, and things will slide down here. So let's try and do that now. I think this angle might be good. The angle is 25 degrees. So one way you can move a face like that is use this move face tool. I'm going to rotate it. I'm going to select this face. I'm going to select this internal edge. I'm going to use that as the reference. I'm going to rotate 25 degrees. That's quite steep, isn't it? And that might not be enough place for a lot of tablets to come through. But you know what? That's what we can check in our assembly. What I think is, and this is getting to the hopper design, FPV Kev has suggested, maybe the ramp angle there is good to help it slide down. You know, we can do a little bit of a test just by having this. Let me show you this one here. All right, just by having a little ramp, putting a tablet on, and seeing what's going to happen. Now, this is quite smooth. I don't have any 3D prints in front of me which are rougher. But like if I'm at an angle like this, is it going to slide down ever so slightly? If I lift the angle up, it doesn't need to be much for that to go down. But once they're all stacking on top of each other, you know, you might want that. We might want that to be higher. That's where I think that 25 degree comes in. I think we can drop it down. Let's drop down to 20. Let's drop down to 15. That could be okay. All right, let's have a look in our assembly. So I'm going to insert this in here. I'm going to press OK there. Just going to hide these patterns. Or yeah, I don't really need them anymore. And the tablet, we can see there's one tablet there. Let's lock our design to the origin. And the tablet, which has one mate here, delete that one. I'm going to put it, I'm going to mate those right planes. But then that tablet, let's just say, I can't actually click it. Let's move it up. Let's say it rotated down a little bit. Let's say it went this way. Because one thing I want to do is make sure it's not getting blocked, you know, as it wants to feed through here. And you can see at this dimension, that's not going to fit. All right. So we'd want to drop that floor. So I'm going to save that back to this file. So what that means this move face, I'm going to change it. Instead, I'm going to do a sketch on this face on the inside. And the sketch lets me put that position wherever I want it. So it doesn't have to be right on this corner. I can still have the same angle or even a greater angle. But I can actually set it back from here so that there's clearance. So one way I can do that is say, hey, I want this much clearance between these two planes. All right, so this edge, are collinear. This line is for construction. Here, I want to have, what do we need? If it's going down in one direction, it was like 30 millimeters. Got my calipers here. 26, 27. So if we say 30, well, that's good. And you can see then when this edge is going to start from. So this is the design thinking coming into it, and design constraints or design intent. My intent is to give this clearance. This is what the geometry might look like. I'm going to bump that up because I think it might be a bit stiff. And this way it matches that face. And I'm not going to extrude the... Will I extrude? Yeah, I'll just extrude the whole thing. I can always shell it out later. So I'm just going up to next and merge. Okay, that looks all right. So it looks like we are going with a hopper design. We'll clear out or tweak things for 3D printing later in the process. What else can we do now to kind of improve how it may function? This side, I'll be some adhesive strips. You don't need to do too much there. I wouldn't mind getting rid of some of these corners. And we probably want to do that before the shell as well. Let's try. I know this is going to break some of the design. But let's have a look at a few fillets in a few places just to give this a bit of a designer touch. 10 mil radiuses. And I think leave that flat until... This is going to be tricky. Let's see what happens here with the shell. And let's remove that. So we've got a bit nicer shape on the outside, but we don't really have the matching curve here. But there's no reason why we probably can't put that in. What's going to happen then, you can see that, like it's only going to shell that face, but then bits are going to get trapped, right? So probably want to shell also this face. And this is before the angle. I can also shell this face. There's just opening up more of that area to be exposed. I don't mind if there's a little bit of overhang here, but that's probably going to sit on top of the 3D print, like the support. So that might not work the best. Going to this side then, have a look at our sketch. Now we've got that curve. Put that here. These and this can be perpendicular. It drops that edge right down to give me plenty of clearance. And also the face that's sketched on now. There is another dangling reference. That's the one that we need to tweak, which is back here. Just remove that. It's okay. And that hasn't added any material on the outside, so that's fine. All right, that looks pretty neat. What I might do is another fillet on this bottom face. Bump that right up. All right, that's looking neater now. A couple of fillets on these front edges. So what I wonder what will happen with these tablets as they come down and I try and pull them out, are they going to get caught on any of those edges? They may do so, but that's the beauty of the 3D printing and doing the DIY. I can just come back and tweak the design afterwards. Now, don't love how those edges are working there. Let's just scale that back. Remove them entirely. We have to do something like even here. See, it's not really doing a nice fillet in that section. Might just skip that one. Okay, and then we've got those kind of sharpest edges all the way around on the inside. Let's kill those. So just going to do an internal radius. Santos Alan Larson, thanks for your question. Can I make a video where you show drafting competencies? Yes, I probably could. That's a good suggestion for some content. Thank you. Do a lot of drafting for molds, for tooling. A lot of the times I do that in consultation with the manufacturing engineers, but I can definitely do that in SolidWorks. So sections, projected isometric, and aligned sections, detail broken out sections. Oh, drafting, you're talking about drawings, not so much drafting as for tool design. I can, yeah. I do have a series in my YouTube playlist on drawings, which shows you how to do things, how to do lots of those things. You should look for the pulley project. In fact, I can show you where it is because you asked so nicely. If you go to my channel and you go to playlists, we could go to, ignore that Pilates one there, model a pulley, view full course. Under this one, you see there's SolidWorks drawings here, introduction and drawing fundamentals. These are some of my very early lessons and videos, but the content is still relevant and would definitely help with your questions. So try those ones out. Thanks for the suggestion. All right, this design, I'm actually going off those fillets. I think we want to go for chamfers instead. I think I want to keep that one and maybe this one here. But the other ones on the outsides, I think they're not quite doing it for me. I think we want to go a bit of a sharper design. The tablets themselves have some fillets, but I reckon we want to use some chamfers here. Go a bit of a sharper, more modern type look. So I'm just going to swap all of those out for chamfers. There is a convert to chamfer button for the fillets, but we're going to leave that. So we've got these ones here. So it's these edges. I wonder, should I do those too? I think yes, if it's going to calculate for me. Yeah. We might put little fillets on those edges. I want to cancel. I'm going to use this fillet still, but I'm just going to bring that right down to, and I'm going to change where these fillets are happening. I think angular might work a bit better. I want to fillet that edge. So I'll put another one in before that. Santos, you're welcome, mate. Thank you for jumping on the stream. Let's go something like this. And then that fillet's going all the way down. I'm going to do a 5mm all the way around the front. Shell. Yeah, that's better. Well, the design's not for everyone. That's fine. It's for me. So, yeah, just want to make sure I'm getting out of this what I need. Get the bodice extrude back in. I don't think I need that. If we look at the section view from the side, there's plenty of clearance now. So I'm going to just make this driven, put this edge in, and I can see those two what it's going to be. So I can still set the dimension, but let's just do it from this face. Doesn't want to do it because that's already got the angle. So let's change that. That's going to set that starting point for that ramp. Going to go to there. Again, I just want to make sure it doesn't do anything on the outside. So we can see this little feature here. I'm going to remove that just using a delete face tool. Okay. That's looking better. These fillets here, where were they? On the bottom, on the inside? Yep. And then around the edges on the inside. So these fillets here are too small for the shell. The shell being 4mm, I think we can reduce that. Let's jump it down to 3mm. And let's bump these fillets here up to 5mm. Now the fillets go onto the inside. This has another dangling dimension, which I'll tweak. So yeah, as you do those kind of edits, often the edges keep coming back, they keep tweaking. That's fine. Quite used to updating dimensions as I make changes. All right, looking okay. Now, what I am missing is the visibility. I think I'm happy with the basic idea of the hopper. Yes, it's pretty easy. I can probably fit in there easily 100 plus. If anything, it might be a bit big. If I think I can fit 2 tablets side by side and they're about 80mm, oh, you know, let's close it up a little bit. So that's where the parametric, I just come back to this first feature. I can go 90 and just reduce that to 80. Everything else stays the same, just makes it skinnier. All right, so we're good now to get ready for 3D printing. So the way we're going to print this is probably this being the bottom. If I was to print it like this, it would just take out a lot of this material, make it infill. What it would do though is make the whole thing a lot heavier. I don't want to have it really heavy on the wall, particularly because I'm just mounting it with adhesive on this face. So it's best to actually remove a lot of that material, and I don't need it. So what I can try and do, there's a shell here that's already 3mm. Let me try and do another shell, 3mm from the bottom. And if it wanted to be really nice, it would just do that and remove that material for me. But because of all the internal radiuses here, it's going to spit back this error. All right, failed to find new geometry to offset. So instead, we'll just do it the cheap way, the easy way. Just double checking it is 3mm. So I'm going to go here, and I'm going to go offset 3. And this might take us a few tries to get right, but let's try and go offset from surface, 3mm, use this face, And you can see there, it's going to remove all that material, and that is, I think, exactly what we need. And if I want to, I can do a nice radius around there, clear it off. All right, so that's reducing a fair bit of weight for the part. Yes, it might use more filament to print, but I'm not so concerned with that. The other thing we wanted this was some visibility of the part. So if all those tablets are inside it, how can we see them? Yes, I can see straight through the top. I might want to see straight through the side. Let's just have a look at an assembly. All right, so we've got sort of a bunch of tablets that are going to sit. Roughly in that kind of position, down a bit more. Okay, they're going to stack up in there. Do I need anything from the side, or should I put anything in? Probably. So with 3D printing, what I've learned, one of the things I've learned through the multi-board tiles and stuff on the wall is I don't really want to do a cut that's like this because it's unsupported. You could do a circle, but then over those top edges, it's kind of spreading out. What you probably want to do is like a hexagon or an octagon, like this, okay, where it can basically do that kind of angle without too much issue. Yeah, and I think so too. Honeycomb's a really nice effect. So there's a few ways we can do it, but I think the easiest way is actually use this face as a reference. And I don't use this tool a lot, but we'll try it here. We're going to use fill pattern. And we can pick our layout, and we pick the spacing between them, the angle, the border. The border is important. And then we pick create seed cut. We're going to do a hexagon. We pick the size of the hexagon, which we want it to be smaller than the tablet, so it's not going to be too big. And then direction. I think it's trying to work it out. I might need a few more settings. I wish I had a saved before doing this. I think I've saved regularly, but maybe not enough. And now it's thinking. I think my spacing between instances is way off. So you see here it says 0.5 millimeter. I should have that much higher. So it's trying to, yeah, he says like create 1,000 of them. So right now I'm just concerned it's going to crash. Which would be annoying. Probably want to tweak this as soon as I can. Come on, SolidWorks. Yeah, there's a few other pattern types. Change the angular spacing, change the spacing to the sidewall, change the direction. Here we'll give you a count of how many. Look, 31,000, because I'm an idiot, right? Trying to do it with this kind of spacing. The 10 mil hexagons, so my spacing should be at least like 15, probably like 16 millimeters. There you go, and then it reduces it to 34. So here we can see now that the pattern, and it's still not quite enough. And I also want to change the angle. So I want to change it 30 degrees, okay, to get them upright. I can also then change let's just change this. 10 mil seems quite big, but it's probably good. 30, no, 20, 25. That's all right, isn't it? I can probably get it closer to the edge. So that's here, 4, that's better, 3, that's better. So that's looking pretty good. Then I can tweak it like this, get it a little bit closer. And this is when I think about the design. So I'm going to press OK here, so then I can save. If we think about the design, I've got that ramp in the middle, and that ramp's at 25 degrees. But if I put that at 30 degrees, that'll match up a bit nicer with the honeycomb shape. This one. So it's also that front edge is 25 degrees. So if I change this, design intent, it might cause me some errors, but let's just try it. I go 30, it changes that angle. So the angle at the front looks nice. The whole hopper is a bit smaller, but then if I change this gap here, just bump that up a little bit, give it a little bit more. There we go. How's that? This big fillet on the inside. This one, we could drop that back. 60. Okay. No, that's looking all right. And that's, you can see how quick that was to do that pattern. And you know, that's kind of neat. Like it's got one gap, one gap, one gap. Not bad for features. Off-road. Hate it when you're on a roll and get 45 minutes or something, you forget to save. Yeah. So I've saved very regularly, probably every 10 minutes, if not less. Just, you know, if I lose 5 or 10 minutes of work, it just kills me. Like I just hate it. So very regularly, Control S. All right, this is looking pretty good. I'm pretty content now. What do you guys think? Is it ready for print? I think the very last step that I would do is put a 1 millimeter radius around the top, maybe 0.5, just to smooth that off a little bit. And then I would test this in the slicer to see how it 3D prints. It has to support, put a bit of support on this edge, so it'll have some support coming in there. I think all these faces here will be okay because of the angles that we've done. All right. Why don't we have a quick look at that just to close off the stream today, just to see if I'm right with that. So with the 3D print, just matte white. This face obviously pretty flat, nothing fancy there. I don't need to worry about the underside, just support that and then rip the supports out afterwards. Yeah, I just want it to be a nice clean print. No lid. Well, think about it this way. If I put a lid on it, then every time I want to put more in, I have to take the lid off and put the lid back on. The whole thing's going to sit hidden in the cupboard. What I want is to be able to open the cupboard door. So it's a base cabinet, open the cabinet door, chuck the box in or grab one and then close the door. I don't think there's any need for a lid. Of course, I could very easily do a lid, like it's a flat shape, and maybe it would be neat. Let's see what it looks like after the print, right? Let's find it. I haven't saved it. Let's save it first. Any guesses to how long the print's going to be? My guess is about 8 hours. It's pretty big. I'm not going to print it at super high quality, but I want it to be decent. No lid. I'm planning on sticking it. I'm planning on sticking it to the inside face of a cupboard door. So when you close the cupboard door, it's covered. You don't see it. All right, here it is. Let me just change the color just so you can see it a bit easier. Basic, high quality, supports. Yes. I like using tree support. I'll leave that. Let me orientate it the way it wants to. And let's press slice plate and see what happens. I said 8 hours. That's my guess. Could be longer, could be a lot longer. If there's no support, could be very quick. There's going to be limited support in this area around here, and then a lot of support underneath. The support underneath, because it's ramped, I think that's what's putting it up 13 hours. So it's changing filament 27 times. That's quite a lot. It actually hasn't done any support in the middle here. It's really weird. Why is it changing filament 27 times? What is this one? Oh, because it's building the tower like that. I don't understand why it's doing that. There's no support here. This is one I'll have to explore a bit further. Yeah. No, it's not multicolor, but multi-material. So I'm using the PLA for the main thing. That'll be a white, but then I use the support for the interfaces. That just means the support can pull off easier. But if the support's going to look like this, here, this is why it's changing layers 27 times, because of those fillets I've got in here. So there's like 1 layer, 2, 3, 4, 5, and it keeps building up to that top one there. So that's why it's changing so much. But given where those supports are, and that there's no support on this front face, which I'm not sure about, but it seems to think that's going to be okay, I would just change and remove the multi-material. So how does it think? It thinks it's going to print all the way across there without issue. Look at that print. It's going like 70 millimeters across that edge from side to side. That edge here is 55 millimeters. Seems risky. I'm going to uncheck remove small overhangs, and I'm going to change my support material to the default. So it's not using different materials. I'll go slice plate, and then hope to see this then all one color and a lot quicker. So 11 hours, still taking a long time. Remove that small overhang. See, now it's going to put support here. I'm okay with that. Because I won't mind, tearing that off. I think that's fine. And then it's got one big tree in the back. All right. So that'll be it. That'll be the one I'll send off to print. Not sending it off on this printer because I need to switch over to a different machine. And that's going to wrap us up for the stream. Just ticked over 2 hours. Did twice as much as I thought we would, which is fantastic. Thank you to everyone that jumped on in the chat. It's the best number of views and concurrent views I've had for a long time doing some streams, so really appreciate that. I think the timing pretty good, doing these maybe every 2 or 3 weeks. And yeah, lots of good questions. So thank you very much for interacting, everyone. FPV Kev, Santos, Off-Road, 526, Artse, Humamichi, Jamie Kirk, thank you as well. Jay, 4444, Dennis, Matab as well. I think that's everyone that jumped in the chat. Awesome to have you and be doing some SolidWorks with you guys. So there we go. Yeah, if you want to join or see when the next stream's going to be, please subscribe. I'll try and schedule them sort of every 2 weeks. I think Thursday nights Australian time works pretty well. I do have a calendar up in the Fully Defined Skool community, so you can always see them there. But yeah, also there's a Discord. Too many places. I need to consolidate a little bit, but yeah, just getting things up and running and going for the year. Have a great week, everyone. Stay fully defined. Thank you, FBV Kev. I'll see everyone in the next stream or video. Catch ya.